Yes, class. Am I audible to all of you? Nuha, Abdul, Mariam,
Yes, ma'am.
Khadija has also joined. Khadija's audio is not connected. Okay. Yes, class. Let's quickly complete with this. Now we start with rotation today. So one thing that was left from last class was inelastic collision we did in 1D. So I told you inelastic collision is comparatively easier than your previous collisions because in inelastic, you have a common velocity for all the uh, velocities that we had initially. They either got interchanged or new velocities developed after collision, right? If two bodies are colliding, once they have separated, it's not necessary that they'll regain exact velocity which was before, right? So in inelastic collision, the best thing and the advantage for our calculations purpose was that the velocity was same, one common velocity. The bodies stick to each other, they got separated, and one common velocity was achieved. Now, elastic collision in 2 dimensions. This is left. Elastic collision in 2 dimensions. This is left. Now look here, class. The only difference that comes here is in 2 dimensions, the body's 2 dimensions are changing is in the sense that we are resolving the velocity because the velocity is in such a manner that it is neither on the x-axis nor on the y-axis. So in such cases, what you have to do? You resolve the vectors along x-axis and y-axis. Understood? See, elastic collision in 2 dimensions. Along x-axis, we'll be solving separately. Along y-axis, we'll be solving separately. Why? Because see, earlier, whenever we did, either it was elastic collision in 1 dimension or it was inelastic collision in 1 dimension, only one component changed, that was changing along x-axis, which was the velocity. So if only one component is changing, you need not change the direction of velocity or need not resolve it, right? Here what is happening, m1 is coming with u1 velocity, m2 is coming with u2 velocity, both are colliding, and when they are separating from each other, they are separating at an angle with the horizontal, right? So that's why here we need to resolve the vectors. Like you can see over here, if m1 body is coming with u1 velocity, so its momentum will be m1 u1. If m2 is coming with u2 velocity, its momentum will be m2 u2. Now collision has occurred here, and now they are separating. So see, their separate velocity of separation here, this is v1 and it is v2. So you have v1 velocity, you have v2 velocity. So now what will you do? Both the velocities are present. How will you solve it? So what we'll do, we'll perform the resolution of vectors. The resolution of vectors we'll perform. Now see what will happen. V1 is making θ1 angle with the horizontal, and V2 is making θ2 here with the horizontal. So what we'll do, V1 we are separating V1 into x-axis and y-axis. So how will it be? See, this will be V1 here, and then this is see here, this is the axis with which the angle is made. So what was the rule of resolutions which we had seen? Basically, resolution of vector says that the axis with which the angle has been made, that is termed as cos theta. Cosine component, cos component goes along with that axis which with the angle is made, and perpendicular to it receives the sine, right? Sine value, so sine theta. So if this is V1 making angle θ1 with the x-axis, so here when you are resolving it, so this becomes V1 cos theta, and perpendicular to it, it becomes V1 sine theta. Fine, this becomes V1 sine theta. Similarly, V2 is present. Now V2 is also having certain angle. This is also making minimum angle. So when you are resolving V2, again, V2's cos theta will be along the x-axis and V2 sine theta will be along the y-axis. Now what you have to do, you have to perform conservation of momentum. I told you momentum will be conserved here. Momentum is conserved. Kinetic energy is not conserved in all cases that we had seen. So please go through the differences which we had seen for elastic collision and inelastic collision. The differences can also come in your theory portion, and the differences will be applied in your derivations as well as your numericals. Now see, conservation of momentum. along x-axis when we are solving. So you have to consider all the forces, all the momentum which you have resolved along x-axis. Look here, initial momentum is m1u1 plus m2u2 before the collision has occurred. If I say over here the collision has occurred, so initial momentum will be m1 into u1. This will be, see, along x-axis, this is m1u1 plus m2u2. This is equal to after collision, which is along x-axis. See, now your velocity, the velocity which initially used to be v1, and here it was also initially v1. Now after resolution of vectors, this is v1 cos theta. So if velocity is v1 cos theta, mass is v1, what will your momentum be? Mass into velocity, m1 into v1 cos theta. Clear? Is this fact clear or not? Why are we not writing simply m1 v1? Why v1 cos theta is coming? Because this time your velocity is not only v1. It has an associated tangent trigonometric component, that is cosine associated. So this becomes m1 v1 cos theta 1 plus m2 v2 cos theta 2. Done. Come to y-axis. Initially, this is just depicting collision occurring. So before the elastic collision occurred, both the bodies were separated, but their y component is not existing. Can you notice? M1 U1 is existing along x-axis, M2 U2 is existing along x-axis. Along y-axis, you have no component associated. Right? So what we'll do in such cases, because we have y component associated after collision, can you see v1 sine theta, v2 sine theta, these are along y-axis, but as such we do not have anything or any vector resolved for y-axis particularly. So 0, we'll simply write for all the initial conservation of momentum this as 0. This is equal to now all your components along y-axis. First one, velocity v1 sine theta, mass is m1. So this becomes m1 v1 sine theta. Fine. Second, mass is m2. So m2 v2 sine theta. Clear? So this becomes total momentum when you will add over here. This becomes m1 v1 cos theta 1 plus m2 v2 cos theta 2. All right. Now what we can do, no, okay, one more thing, class. Here we haven't put the sign convention. If this velocity, see both the velocities here along x-axis were in the same direction. V1 cos theta was also pointing towards the positive x-axis. V2 cos theta was also pointing towards the positive x-axis. But can you see V1 sine theta is pointing towards positive y-axis. V2 sine theta is pointing towards negative y-axis. So you have to apply the sign convention over here. One has to be positive, other has to be negative. So you choose something. Let's take V2 and sine theta to be negative. Any one you can choose. So this becomes minus. Instead, I'll erase it over here. I'll erase it from here. So this becomes this after application of sign convention. Now we can at least equate them. These are sine theta, not cos. M1 V1 sine theta minus M2 V2 sine theta 2. So M1 V1 sine theta 1 is equal to M2 V2 sine theta 2. Both of these are equal. Now see, yes, in our elastic collision, in elastic, only E, elastic collision, kinetic energy is conserved. That's why I'm saying, please remember that difference table which we have done, because separately also it will be asked. It has the application in the derivation, and lastly it has the application in numericals. So kinetic energy is conserved. So if kinetic energy is conserved, you can again use all the equations, half m1 u1 square plus half m2 u2 square is equal to. Now see class, tell me one thing. Is kinetic energy scalar quantity or is it a vector quantity? Scalar or vector kinetic energy? Yes, Abdul.
Is it scalar?
Scalar. Very good, Mariam. It's scalar quantity. This is a scalar quantity. So, Nuha, Khadija, Abdul, you are not aware of the fact that energies are scalar quantity. Didn't we discuss this entirely in the lesson work, energy, and power, which was completely based upon scalar quantity? We are studying work, energy, and power only. I told you collision is a part of work, energy, and power only. And I told you work done is a scalar quantity. We didn't use vector anywhere. Is there any doubt in this part that you people didn't answer? Only Mariam could. Work, energy, power in the lesson. Continuously, I've been telling you people that energies, work done, power, all these are scalar quantities. Here, it's the first time that velocity came. That's why we had to resolve it. Otherwise, we wouldn't. Momentum, velocity, these are vector quantities. If you people will not answer, then I'll assume the fact that you people have not understood. Anyways, half m1 v1 square plus half m2 u2 square. See, these are the initial kinetic energies. Now see class, when I'm talking about the final kinetic energy, so as you have mentioned that kinetic energy is, Mariam has mentioned that kinetic energy is a scalar quantity. So do we require v1 cos theta, v2 cos theta, v1 sine theta, or v2 sine theta? We do not want the resolution of vector to occur because vectors aren't needed over here. Our kinetic energy is half m v1 squared. So we'll use it completely because kinetic energy does not depend upon the resolution of vectors. It's not necessary for it. Fine. So this equation you will use, and if any question comes, this is how you are going to solve it. It's just that you have to remember this is just showing collision occurring. That's it. Here. Then collision has occurred and the bodies have separated with different velocities. Note it down. Any doubts if you people are having, let me know. Yes, class. Now starting with chapter number 7, motion of system of particles and rotational motion. So see, most of the portion of this lesson, the circular motion part, we have already done separately in circular motion. Remember friction and all, we did it together. So all the portions which are unique for this lesson, that we'll be discussing over here. Now, motion of system here, basically in the rotational motion, we'll be focusing on the topic rotational motion. Now, first comes the concept of rigid body whenever we are discussing. And why is the name of the lesson motion of system of particles? Now see, reason behind this is whenever we say rigid body means a body that is fixed. You cannot compress it and change its shape. Even if you are applying compressive forces, shear forces, this you will study in mechanical properties of solids also. So there also you will be studying that whenever a rigid body force is applied on a rigid body, shear forces are occurring, tangential forces are occurring, bulk forces are occurring, that are changing its shape, but such a slight change in shape is occurring. That is almost negligible. So body having a definite shape, definite amount of substance which is not being increased is called as a rigid body. Fine. Now, whenever we say, suppose I have taken this rigid body. Now, inside this rigid body, there are lots of particles which are present. See, whenever we talk about rigid bodies, it's not one particular system that is present. It's made up of tiny molecules and molecules and molecules, and finally the whole body is constructed. So on a molecular level, you have these one molecule which is attached to another, then attached to another, like this, all the molecules are present. So when the body moves, when the body begins its motion, what happens if I say this block is moving with certain velocity v, it means each of these particles, this particle, this particle, this particle, this particle, this particle, all these individual particles are moving with their individual speeds, which is this speed. Understood? When the entire body is moving, it's actually all the particles which are moving. But the speciality about rigid body is that this separation between the bodies, see this separation, if you see, or if you see this separation, there isn't any change in the separation between two bodies. Fine. If there are two bodies, then there is no separation between these bodies. Both the particles will remain in the same distance when they are moving. This is one of the characteristics of rigid body. Two particles are present, their separation is r. Within the entire bigger object, their separation will still be r. All right, separation will still remain as r. So all the bodies are present, all the particles are present. Just a second, class. Yes, so see, when there is a separation, both the particles are separated by a small separation. Now see what happens. This separation will be throughout this. Now we have a concept of center of mass that I'll be discussing. Now see, so rigid body is what? Body having definite shape and size. During motion, separation between 2 points on a rigid body does not change. This I have discussed with you. Now when we are saying system of particles, they can be discrete, they can be continuous. System of particles means not a single particle is present, lots of particles are present which are clubbed together. All right. So when I say discrete, it means one particle is here, one particle is here. Fine. One particle is here. All of these particles are present in a diffused manner. They are scattered. That is what is meant by discrete. When I say continuous means all the particles are aligned one by one another with no separation. Continuous, all the particles are present. Fine. So these are the two types of particles that are existing. Note it down, note the introduction part, then I'll discuss more details. Now class, the types of motion that we'll be studying. See, when the body moves in one direction, this is known in one axis, that is known as translation motion. All right, it can be in two axes also, that is known as motion in a plane. Now, when the body's axis is fixed and it begins the rotational motion, that is known as simply rotation motion, pure rotation. When there is mixed rotation also and translation also, like if I tell you, if there is, suppose I have taken my phone, I have kept it like this. Now I am applying a force. This is translating. This is just moving. See, the phone was here. This is just moving like this. Fine. So this is known as translation. If you look at a fan, the axis is fixed and the blades are revolving around it. The axis is fixed and the blades are revolving around it. So that is rotation motion. If you see the example of tire, vehicles when they are moving, the tires of the car, those are rotating also as well as they are translating also. So this combination of translation with rotation simultaneously, this is known as rolling motion. So we'll discuss rolling afterwards. First, let us focus on rotation. Translation we have already studied in the initial lessons of kinematics. Rotation we have to focus on. Now see, as I told you, all these particles are present. Which particle will you define to assign the specific velocity of the body? You cannot. You have to have a point which depicts or which represents all the other points, all the other particles. That particle is known as center of mass. Center of mass is basically that point which shows as if the entire mass is concentrated. It means that suppose there's a body and I have taken its center of mass. So even if I replace the entire system by only that center of mass, nothing will change. Entire velocity of center of mass will be depicting the entire velocity of all the molecules, because depicting the individual velocities, individual accelerations of every particle, every molecule is not possible. Right, obviously it's not possible to write because there are not only 2, 3 or 4 particles present in a system. There are millions and infinite particles present. So it's difficult and it's impossible to define each of them. You have to have a representative for all the particles which is depicting all of these parameters with the help of just one particle. And that point at which entire mass is supposed to be concentrated is called center of mass. Entire mass is concentrated means even if I remove that solid object, even if I remove that rigid body, my just center of mass will be sufficient enough for depicting all the parameters. And it's not necessary. In some systems, we have the center of mass located also. So center of mass does not mean that it is present exactly at the symmetrical center of the body. It can be, see, if suppose this is a random system, center of mass can be located here also, center of mass can be located here at the center also, and center of mass can be located here also. Fine. And this is a concept of translational motion. We basically use it. Now coming to the formula portion. Suppose there is one particle, A point. This separation is R1. Mass of the particle is M1. I have taken one more, M2, R2 at the B point. I have taken one more, C point, R3. This is the particle, mass M3. And so on, I have taken N number of particles whose separation is Rn, point is Nth, and mass is also Mn. So what is the generalized formula? See, we have everything in plane. It's not necessary that you have things situated in along one axis only. So for x-axis, for y-axis, different types of these are existing, center of masses. Generalized formula of center of mass is basically M1R1, M1 R1 plus M2 R2. So like this M3 R3, M4 R4. Finally, we have Mn Rn divided by sum of all the masses which are present. that is M1 plus M2 plus M3 plus M4 up till Mn. Fine. So specifically for x coordinate, it will be M1 x1 plus M2 x2 up till Mn divided by total mass M1 plus M2 plus Mn. For y-axis, it will be M1 y1 plus M2 y2 plus Mn yn, whichever 5 are there. So M5 y5, whatever is given, divided by M1 plus M2 plus M3 up till Mn. Last is z-axis, M1 plus Z1 plus M2 plus Z2. Like this you have to do. So generalized formula also I've told you, and specific x, y, and z also I've told you, because anything can be given in the question. Note it down, write it down, then we'll see question also. See class, we'll be using this formula only. Now x-axis and y-axis both are there. So z-axis, we don't need it right now. Now see, we'll mark the coordinates. It's an equilateral triangle and nothing is mentioned. How will we know the masses? M1, M2, M3 we can decide. But what about R1, R2, R3? So at the origin, if you see, what are the coordinates? Coordinates are 0, 0. So x1 is 0, y1 is 0. Problem solved. Come to this point. What are the coordinates? From x-axis it is a, but from y-axis it is 0. So a, 0. In your class 10 till your class 10th, whenever you did mathematics questions and trigonometry and all, there in geometry, you must have done these coordinates, right? So coordinates are found like this only. X, Y, Z. This is the order of writing coordinates. Usually X, Y, these are sufficient, but in your physics, Z axis can also be involved. Now, point is how to find out this coordinate. First one was easy, 1 kg, 2 kg was also easy, 3 kg kaise nikalen? 3 kg ka nahi pata hai. So how will we find out for 3 kg one? Look here. First X axis. So look, this point is coinciding with X axis at which point? This is coinciding with x-axis at which point? See, can you see this is half of it? So x-axis will become a by 2. Like this. This will become a by 2. Fine? A by 2. Now second point, a by 2 comma second one. So we have to find out which point is this. This is some point. We have to find out which point is this. Now, look. And yes, whenever the question is calculate position of center of mass, automatically all the axes you should write it down. Now look class, how to find out this point. We want this, that is only y coordinate, right? This axis is only our y coordinate. The way this was x, a by 2. See class, this was no a by 2. And this is the y-axis which we have to find out the y coordinate. And this is a. So under root a plus a by 2 whole square. This becomes under root a square plus a square by 4. Right? So that becomes 2a by 4. So this will become 2a by 4. 4, no, here we'll subtract it. Here we'll subtract it. Otherwise that will, because we want to find out the perpendicular, not the hypotenuse. So we'll subtract 4a minus a square, 3a square by 4 under root. So root 3 will be left, a by 2. Root 3a by 2. This is the coordinate. What is this? This is root 3a by 2. Now is it a difficult question? You have all the values. You have, see, you have m1, x1. X coordinate, let us find out. Center of mass for x. m1, 1 kg. m2, m1 into r1, 0. Plus m2, I'll write down the formula first. What is the formula? Formula is m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. Why only till 3? Because 3 masses are given. So what is m1? m1 is 1 kg. x1, this is x1, y1. And this is m1. So x1 is 0 plus m2, this is m2, this is x2, this is y2. m2 into x2. So 2 kg into a plus m3. This is m3, this is x3, y3. So m3 into x3, that is this is 3 into a by 2. 3 into a by 2 divided by 1 plus 2 plus 3. So this becomes how much? 2a plus 3a by 2 divided by 6. Right? So this becomes, this a will go, 2 will come down 12. So that becomes 7a by 12. That is x COM. Similarly, you will calculate y center of mass. M1 y1 plus M2 y2 plus M3 y3. M1 plus M2 plus M3. So M1 is 1 kg, Y1 was 0, M2 was 2 kg, Y2 was 0 again, M3 was 3 kg, and this was root 3 A by 2 divided by 1 plus 2 plus 3. So the 0, 0, 3, this becomes 6, so this becomes root 3 A by 4. So this is YCM, that was XCM. This is how you have to find. First tell me, is this clear to all of you? Abdul, clear? Yes, no? Khadija?
Yes, sir.
Khudeja Bashir? Clear, Khudeja?
Yes, ma'am.
Mariam? Understood? Mariam?
Yes, ma'am.
Nuha? Clear? Nuha Sheen?
Yes.
Clear? Do one thing, you people start writing it down where at whichever point you're not able to understand why this has been written. Please unmute yourself, ask, or it's the best way is write in the chat column and ask. This is a very basic question. And it's just that, see, you had to find out this point, that is this side, and you have to keep it in the form. How did you get root 3 a by 2c? Mariam, if we have to find out this side for y, because this is for x. So see, we know this is a by 2. This is a by 2 because it is coming in the middle of a. A by 2 is there, a is there, and this unknown side is there. So apply Pythagoras theorem. So y square plus a by 2 whole square will be equal to a square. So y will be equal to under root a square minus a by 2 whole square. So when you are
Okay,
squaring it, clear?
Yes, I got it now.
Abdul, see, root 3 a by 4 is the final answer for YCM. For X center of mass, I told you, no, X and Y we'll find out separately. So X is this is for Y. So both the answers you will write, or you can write it as a coordinate also. All right, class. Now please appear for your after class assessment. We'll continue this on Thursday now.